So you've probably played around with an AI to write an email, maybe even a poem. But have you ever stopped and wondered how it actually works? Well, today we're going to pull back the curtain and really demystify the whole process behind how AI writes.
I mean, you've seen it, right? You type in a prompt and boom, out comes this surprisingly coherent, sometimes totally brilliant piece of text. But how does it do that? Is it actually thinking? Is this some kind of magic?
Well, the reality is actually simpler, and in a way, even more brilliant than you might think. It really just boils down to one single core task: predicting the most probable next word over and over and over again. Let's see how that incredibly simple idea scales up into something amazing.
So, the name we use for these things, a large language model, or LLM, it actually gives us the first big clue. It's a language model, and, well, it is large.
All right, let's break that down. A language model, at its heart, is just a prediction engine. Its entire job, its whole reason for being, is to guess the probability of what the next word in a sentence should be. But the large part, that's where the real power comes from.
And listen, when we say large, we mean a scale that was pretty much unimaginable just a few years back. We're talking hundreds of billions of parameters. You can think of those as the tiny little knobs and dials the model tunes while it learns. It's been trained on trillions of tokens, which are basically just pieces of words, from a huge chunk of the internet, books, you name it. And all of this, takes a massive amount of computing power. But at this insane scale, something amazing happens. New abilities start to emerge. But this massive size also creates a brand new problem.
Okay, so you've got this enormous brain. But how do you manage all that size and complexity without everything just grinding to a halt? Well, the solution is actually pretty clever.
Think about it. Do you really need to fire up a brain with 100 billion parameters just to answer a simple math question? Of course not. That's total overkill. It's like using a sledgehammer to crack a nut. There's gotta be a smarter way to do this.
And this right here, this quote gets to the absolute heart of the solution. You wouldn't ask everybody in that room, would you? No. You go right to the specialist, the mathematician. And guess what? LLMs do the exact same thing. This whole idea is called a mixture of experts, or MOE for short. So instead of one giant monolithic brain that has to do everything, the model is actually made up of a bunch of smaller, specialized little networks, the experts.
So here's how it works. It's a really dynamic process. Okay, so your query comes in. Instantly, this tiny little router network, it's like a dispatcher, takes a look at the job, and it decides, aha, this is a job for the history expert, and it sends it over there. And the upshot is that only a tiny fraction of the model's total brain power gets used, which makes the whole thing incredibly fast and efficient.
So what this means is you get all the knowledge and power of a gigantic, maybe even a trillion parameter model, but you're getting it with the speed and the cost of a much, much smaller one. It is literally the best of both worlds. You get the massive scale and the efficiency.
All right, so now we have this giant, super efficient brain. But how does it actually write? How does it string those words together to make a coherent sentence or a whole paragraph?
Okay, so if the model always picked the single most likely next word, that's a method called greedy decoding. Its answers would be, well, super predictable and kind of boring, right? You get the same answer every single time. So instead, what modern LLMs do is something called sampling. They look at a whole pool of likely words and then pick one based on their probabilities. And that is where the variety, the creativity, the magic seems to come from.
But wait, how do we control just how creative or random that sampling gets? Well, as it turns out, there's a dial for that.
It's a setting, a parameter called temperature, and you can seriously just think of it like a creativity knob. It basically controls how adventurous the model is going to be when it picks that next word.
So when you set a low temperature, the probability distribution gets really, really spiky. The model gets super confident in the most obvious, highest probability word. You can see it right here. It's giving a 90% chance to the word the. This is perfect for when you need factual answers. You want precision, you want predictability.
But then you crank that temperature dial up and look what happens. The probabilities completely flatten out. The model gets a lot less certain and it gives those less common words a much better shot at being picked. All of a sudden, more surprising words become real possibilities, and this is what leads to those creative, diverse, and sometimes, kind of weird and unexpected outputs.
And this brings us to a really crucial point. You have to understand, the giant LMM model itself, it's just a deterministic machine. It's just calculating probabilities. All the creativity, all the variation, that feeling of spontaneity, it all comes from this one final step, how we decide to sample the next word from that list of possibilities. That's it.
So let's wrap this up. What's the secret recipe for how an AI actually writes? Well, it's not magic. It's really just 3 key ingredients. First, a really simple core task. Just predict the next word. Second, massive, massive scale. Train it on a gigantic amount of data. And third, some really clever engineering, using tricks like mixture of experts and temperature to make it all work efficiently.
So now that we understand the mechanism, the real question isn't how does it work anymore. The question is, what can we build with this? When you strip away the magic, you're left with one of the most powerful, creative tools ever invented. The real question is, what are you going to do with it? Thanks for joining this explainer.